Let us try to master strategies to solve linear equations with the help of these examples. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We'll take up solution of few linear equations in this particular video. Solving linear equations is actually the first step towards learning algebra and problem solving. We'll understand the techniques applied to solve such equations. We'll begin with very simple questions like x plus 5 equals to 12. You can answer these questions even by intuition or verbally. But as it gets complicated, as you can see, we might have to use different techniques to answer. So beginning from the very simple ones, we'll complicate and one by one learn the techniques involved in solving linear equations. I hope you'll understand and appreciate it. In case you want to learn from me, you can always send an email on the address given. Some of you who have already done many examples solving equations, they can take this as a practice test. Perfect. So let's begin with the very first set of 3 questions here where simple operations are involved. We'll understand this strategy. First equation here is x plus 5 is equal to 12. So we need to find the value of x. That is what solving equation is. So we do not want 5 here, right? So in that case, we can take away 5 from both the sides, correct? So when you take away 5 from both the sides, you actually get x on the left hand side, and on the right hand side 12 minus 5 is 7, and therefore the solution is that x is equal to 7, right? You can check the solution also, right? So if I substitute on the left hand side 7 for x, then we know 7 plus 5 is indeed 12, which is the right hand side. So that is correct. So solving means finding the value of x. It's a good idea to begin with checking your answers also. Now let's take up the next question, which is 1/3 of x equals to 6. Now basically we need to do the reverse operation. Last time the reverse of plus was minus. You get the idea. So we are learning reverse operation in this particular case. So the strategy you can say is reverse operation. So what is the reverse operation of division? It is of course multiplication, and therefore what are we going to do? Well, we are going to multiply by 3 on both the sides, right? So if I multiply by 3 on both the sides of the equation, I am not changing the equation. But you know 3 divided by 3 is 1, and therefore I could write this as x as equal to 6 times 3, which is 18. And once again you can check your solution, right? So 1/3 of 18 is what? 1/3 of 18 is 6, and therefore we see left side is equal to right side for x equals to 18. Makes sense, right? So with that we have done the first 2 questions, and we are now combining both the skills to do the third question. You see how the strategies which we have learned will be applied. Do you see that? So in this case, I like you to pause the video, apply both the learned techniques and solve. So we have 3x plus 12 equals to 17. First step being that we'll take away minus 2, correct? So when you take away minus 2, you really get what? Well, in that case, you get 3x on the left hand side, and 17 minus 2 is 15. Now what should you do? Well, reverse of multiplication, as you know, is division. So we are going to divide by 3 on both the sides. As soon as you do that, you can see that 3 and 3 cancel on the left hand side, and so what you get is the value of x, which is 15 divided by 3, or 5. You get the idea. You understand how we have done the reverse operation one by one and then found the solution. You can again check your solution. I will leave that for you, right? Substitute x equals to 5 in the given equation. 3 times 5 is 15 plus 2 is 17, and therefore it is the correct answer. Does it make sense to you? Right? It does, right? So now you're ready to take up more challenging questions. So here, once again, we have both the operations now being involved in every question. Perfect. So we'll gradually get into questions which will involve many other techniques, including working with fractions and working with the distributive properties. Correct. Now let's do the question number D, which is 3 over 2x minus 2 equals to 7. Now, in this set of questions, I'll show you a solution in a different form. Earlier, we were adding 2, right, on both the sides, in this case, to solve. Now, see how I transpose the values, right? So when it is negative here, we want to isolate x, right? So the strategy here basically is to isolate variable, right? Means nothing else should be there. So we don't want this 2 here. We'll transpose 2 to the other side. Means let's take it to the other side. So when you take plus to other side becomes minus, minus becomes plus. That's the whole thing, right? Which we're going to understand now. So 7, so it becomes plus 2. Do you see that? Now both the equations are same. 3 by 2x minus 2 equals to 7 is same as 3 by 2x equals to 7 plus 2. Get the idea? So now we'll rewrite this as 3 by 2x as equal to 7 plus 2 is 9. Now what is the reverse of 3 by 2? Well, 3 by 2 is like times 3 divided by 2. Reverse will be times 2 divided by 3. So we'll again transpose this multiplication and we'll multiply 9 now with 2 by 3. Do you see that? So it's kind of a cross multiply which we have just done. And now we could multiply 9 with 2, which is 18, divided by 3. We are going to get the answer, which is 6, right? So we get x as equals to 18 divided by 3, which is 6. Now, for some of you, it may be helpful to see that we could simplify first. Dividing by 3, we get 3 times 3 as 9, and 3 times 2 as our answer, 6. Does it make sense to you? So do you see we have learned isolate variable, and what are we doing here? We are transposing, right? So taking the terms from left to right and sign changes, right? So that is the critical thing. Now let's apply this strategy learned with the next question. So can you please pause the video and see how do we perform this operation of transposing terms. So we have x by 2 plus x equals to 6. Well, in this case, should you do transpose? No, we need x, right? So now in this particular case, what should we do? Well, on the left side, we have both the terms involving x. So we'll now combine them, right? So to combine them, we are going to take the lowest common denominator, right? So lowest common denominator is 2 for us. So our strategy now is to get rid of fraction. Get rid of fractions. So how do we get rid of fractions? Since the lowest common denominator is 2, we'll multiply every term by 2. Get the idea? Okay, so let's rewrite this expression, which is x by 2 plus x equals to 6, right? So I want to multiply everything by 2, right? So this is times 2, this is times 2, and that also will be times 2. So we multiplied every term by 2. So 2x divided by 2 will just give me x here, right? And here I got plus 2x, and this is 12. So what we get here is x plus 2x is 3x equals to 12. And now dividing by 3, we get 12 divided by 3, which is 4. Makes sense? Slightly tricky, a difficult question. Do you see how we have landed up in a very difficult question now? Do you understand how we solve this particular case? This is another strategy. Get rid of fractions. You get the idea, right? Now, another strategy with the next question. X minus 3 over 2 equals to 5. Do you suggest what should we do? Well, the strategy now being applied is called cross multiplication. So cross multiplication is see this 2 will get multiplied there. This is in a way same as multiplying by 2 on both the sides, right? But it gives you an effect of cross multiplication. So let me just show you how it works, right? So we have x minus 3 divided by 2 equals to 5, right? So what are we going to do in this particular equation is that we are going to multiply both sides by the common denominator, which is 2, right? So multiplying by 2 makes sense, right? So as soon as you do that, this 2 and 2 cancels on the left hand side and we get x minus 3, correct? 5 times 2 being 10, we'll take 3 to the other side. So x is equals to 10 plus 3 or x is equal to 13. Do you see that? So we have found this solution for the equation, that is the value of x, which is going to satisfy the equation. You can always substitute 3 here, 13 here. 13 minus 3 will be 10 divided by 2 is 5. You get the idea. So in this set, you have learned 3 different techniques. One, which started with transposing in the last example, and then common denominator, multiply to get rid of fractions, and then cross multiplication. So when you have a situation which is kind of a ratio of proportions, I should say, right? Apply cross multiplication. Now you are armed with most of the strategies required. So let's move on with some difficult questions. Now what we have done here in this set of questions, we have placed x on both the sides of equation. So when you have both the sides involving x, you have to bring them on one side. So that is an additional step which is required. So let's perform the operations on the very first one, which is 8x plus 5 equals to 5x minus 7. So transpose, right? Variables to left. So we'll keep variables to lefts. Constants on right. So if you follow the simple rule, then we have 8x, which is a variable. We'll keep it here. 5 will take it to the other side, 5x on the left side. And when it comes here on the left side, the sign changes. We have minus 7 minus 5. Makes sense? Correct? Now 8x minus 5x, like apples, 8 apples take away 5 apples. They are similar terms, right? Like terms. We call them like terms. So you can always add and subtract like terms. 8 minus 5 is 3. So we get 3x equals to minus 5 minus 7 is minus 12. So we get 3x equals to minus 12, or x is minus 12 over 3, which clearly is equal to minus 4. Makes sense. So we could get negative or positive answers, and we could also get answers in fractions. Perfect. Well, there could be equations which have no solution also, right? Anyway, here is a situation where we have one solution, which is x equals to minus 4. Perfect. You can always substitute this value and check. 8 times minus 4 will be minus 32, and minus 32 plus 5 means we have minus how much? 27, right? So, and on the right hand side, 5 times 4 minus 4 is minus 20, and minus 20 minus 7 is minus 27. So both sides are minus 27. Perfect. Let's do the next one. In the next one, we have, let's rewrite the question here. 2 times x plus 5 equals to x plus 3. So the variation here is that we have to open this bracket, applying the distributive property, right? So you have to multiply with a monomial, a binomial. So this is a binomial which has got 2 terms, and what we are trying to do here is distributive property, right? Let me write down. So when you distribute 2, multiplied with both x and 5, what do you get? 2 times x is 2x, and 2 times 5 is 10. Do you see that part? And we have x plus 3. And now apply the like term property which we learned in the last example. Transpose variables to the left side. So we have 2x minus x equals to 3 minus 10. Take the constants to the right side. Understand? 2x minus x is x, and 3 minus 10 is minus 7. So in this case, the solution is x equals to minus 7. Perfect. You can verify by substituting x as minus 7. So we have 2 times minus 7 plus 5, right? Which is 2 times minus 7 plus 5 is minus 2, which is minus 4, correct? On the right hand side, if I have minus 7 plus 3, I get minus 4. Do you see both are equal, correct? So it is the right solution. So you should perform the check on your own once you've done the question. I'll now like you to pause the video, answer this particular question, which is applying the strategy we just learned. Perfect. In case you want to learn from me, feel free to send an email on the address given. Now, we have 3 times x minus 5 plus 9 equals to x. So, apply the distributive property, we get 3x minus 15. Take this 9 to the left side, right? So, we'll do this as x minus 9 for now. Bring x to the left side, so we get 3x minus x. 15 to the right side, it becomes plus 15. I wrote it before minus 9. 3x minus x is 2x, and 15 minus 9 is 6, and x will be 6 by 2, which is x equals to 3. Makes sense. So that flow has to come while you're solving these equations. So I'm just waiting for you to get this flow. Once you get this flow, then feel free to try more examples from the playlist. Perfect. So I hope these steps are absolutely clear. Once again, we have applied the property of bringing all the variables to the left side and constants to the right side. We have also introduced to you the property of distributive property, where we are multiplying a monomial, a constant this time, with a binomial, which is 2 terms, right? Okay, let's move on and take the next set of questions. I hope you are enjoying this journey of learning along with me. Now see, what we have done here is that we have the x values in the denominator. Truly speaking, this is not a linear equation, right? So this is a non-linear equation. Let me write down. So we are into our next level of questions where we'll convert non-linear equation to a linear format. Now remember, since x is in the denominator, you cannot divide by 0. So in this case, x is not equal to 0, and that is called the restriction, okay? So this is a restriction. So such equations are actually rational equations. Let me write down. But what we are trying to do here is rewrite this in terms of a linear equation and apply the strategies which we have learned to solve them. Perfect. So most equations involves sometime during the journey of solution, linear equation solution. You get the idea. So linear equation is the basic of algebra. Right. So now here, what is the common denominator? So LCM, lowest common multiple, is 2x. So we'll take 2x as a common denominator, right? To make this as 2x, we have 1 here, but here we have to multiply by 2, so get 4, right? So equals to 3. You get the idea. So what we did was, we wanted to make 2x is the denominator, so we multiplied the second term by 2 over 2. Multiplying by 2 is just multiplying by 1. Doesn't change anything, right? And now you can see what we have is 5 over 2x, right, equals to 3, correct? So a different kind of equation altogether. 5 over 2x is equal to 3. We need to now isolate x. What can I do? So let's rewrite this equation and see the different strategies which we can do to solve 5 over 2x equals to 3. Well, x, this time we are going to take it to the right side. So we can have cross multiply x. So we have 5 over. Let's multiply that by 2x itself just to make it simple, right? So we'll just cross multiply. Well, there are many ways to do it. We are doing it like 5 times 3. 5 equals to 3 times 2x, correct? Which gives you 5 equals to 6x, correct? Now to isolate x, I'm going to divide by 6. Right? Now, divide by 6. So we get 5 equals to, dividing by 6, x equals to 5 by 6. You get the idea. So that is how we got our solution. So we had to do some more manipulations. You can be very comfortable at this level once you practice questions before this, correct? Well, let's try to understand. What we try to do here is try to solve a rational equation and in a linear way with the strategies which we learned earlier, correct? Let's move on. We have 3 questions like this. This is the first one. Now here is the second one where we have denominator 3x and 2x, okay? So let me rewrite this. So 1 over 3x minus 2 over 2x equals to 2. So what is the common denominator? The common denominator, let me see, lowest common multiple or LCD we could say is 6x, right? So what we could do is multiply every term with 6x, right? Times, so multiply each term. By 6x. See what happens. So we have 1 over 3x minus 2 over 2x equals to 2, right? So we are multiplying each term with 6x, right? So 6x, 6x, 6x. So now you can see 6x and 3x, when you divide it, you get 2 here, right? And 2x, 2 divided by 2 is 1, and you get x and x cancel, you get minus 6. You get the idea? And over here, you get 2 times 6 is 12. You see that. So one step we have actually simplified. Get rid of fractions. This is a very effective strategy. Now, on the left side, we have got 2 minus 6, which is minus 4. Let me change the ink, right? So we have on the left side, minus 4 equals to 12x. And dividing by 12, we have minus 4 over 12 equals to x, which is minus 1 over 3 is equals to x. So we have our solution, and the solution is x equals to minus 1 over 3. Makes sense. So you could get negative answers, positive answers, also fractions as your answer, right? Perfect. So have a good look at it, see how we solved it, right? So once again, here x should not be equal to 0 since you cannot divide by 0. And these are called rational equations. The last one here is for you to test out the strategies learned. But also I'll introduce one more strategy here. And the strategy which I'm going to introduce here is cross multiplication. Clearly, we have a proportion kind of a statement, right? So we are writing here 1 over 3 times x minus 2 equals to 2 over 2x. So when you cross multiply, we get 2x on this side, and on the right side we get 2 times 3 times x minus 2. Makes sense? I introduced the square brackets just to make it very clear for you how we've done it. Now let us also look into the restrictions. As you know, denominator cannot be 0, so x is not equal to 0, but x can also not be equal to 2, because 2 will make the left hand side 0. Make sense? So there are 2 restrictions for this particular rational equation, right? So this is a rational equation. So I am taking this liberty to moving on from linear equations to rational equations to give you a link, a bridge between the two, right? Okay, great. So now let's open the bracket on the right hand side. So we get what? We get 2 times 3 as 6. But what we could do also is we could divide by 2 on both the sides also, right? We could divide by 2 on both the sides also. So in that case, what really happens is that we could have simplified it earlier also. We could have done that also. Okay, anyway. For now, let's keep it. So we have 2 times, let's open the bracket here, 3x minus 6. Is that clear to you? And in the next step, I'm going to just simplify this, divide by 2 on both these sides. So let me do it here. So then this 2 and 2 cancels, right? So we could write this as x equals to 3x minus 6. Now we can bring the x terms to the left side. X minus 3x equals to minus 6, minus 2x equals to minus 6. X is equals to minus 6 divided by minus 2, which is 3. So x equals to 3 is our solution. So x equals to 3 is the solution of our question. Perfect. So I hope with this you've learned great techniques. In case you want to learn from me, you can always send an email on the address given. I would like you to review the solution of these types of questions and write down the techniques learned. In the very first one, we learn the operations, which is called reverse operation, right? And then we learn the technique of ratios and proportions, which is cross multiplication. And then we learn the technique for having a lowest common denominator and get rid of fraction, right? And then we also applied distributive properties and transpose terms. Correct? And at the end, we actually solved rational equations with the help of these techniques learned, right? So I hope you find it interesting and useful. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.